So last time we did the limits from the graphs, where you were given a graph and you kind of just like looked at it and said like, oh, there's the answer, like to sort of zoom in on the point and say, oh, where it's going. We're going to do two new types of limits today. On the front side of this, we're going to do the limits to positive and negative infinity. That is just end behavior. Negative infinity is the left side, positive infinity is the right side. I call this who's in charge here. And you did learn this in Algebra 2, and I did cover it when we did rational graphs. You look at the degree of the numerator and the denominator and compare them. So here's the rule. The numerator degree is smaller. It's automatically going to level off at 0. Here's how my brain does that. If you go out towards really, really huge numbers and the denominator is getting bigger quicker, you get a situation like this. A half, a third, a fourth, a fifth, a sixth, a seventh, an eighth, a ninth, until you get out to 1/1 trillionth. And if I handed you 1/1 trillionth of a piece of cake, you would be like, gee, thanks, Miss Cole, because that is, okay, so it's going to level off at 0. I think the second one is everybody's favorite version of events. When the powers are the same, you just use the leading coefficients, and that's easy because it's just the numbers that are sitting right there. And then these were the slant asymptotes. Do you remember that? That was the new thing this year. Remember going like this? Okay. If you get the numerator degree bigger than the denominator, it's going to be a slant asymptote, which means it either goes up or down. So if you figure out that it's that one, you have a 50-50 shot of just guessing. It's either positive or negative infinity, but you're just checking the signs at that point. Now, if you aren't sure who's in charge, an exponential, which that's like e to the x, all right, remember e? Okay. Grows faster than a polynomial. A polynomial is like x, or x squared, or x to the third, or x to the fourth, or x to the fifth. That's like a polynomial. And that's going to grow faster than a logarithmic. So if it's like who beats who, basically, that's the order that it's going to go in. Okay? So you're looking for who's in charge here. So when you go to positive or negative infinity, it's who's in charge. So look at this first one. I usually just circle them. In the numerator, do you see how the third is the biggest power? So this term is in charge. That's the one we want to look at. And in the denominator, the 5x cubed is the one that's in charge. You basically ignore all the rest of it. Okay, so just look at those. Now, which situation is that we have? We have a 4x to the third and a 5x to the third. So is that like the first situation, the second one, or the third one? Good, they're equal, right? So since the powers are equal, we're going to use the coefficients, which is what? 4/5 is your answer. It's super easy, but you guys are going to have to wake up, okay? So look at the next one. In the numerator, it's the x. That's x to the 1, everybody. In the denominator, it's x to the third. So which situation is this? The first one, the second one, or the third one? The first one. All right, the numerator 1 is smaller than 3. So it's automatically going to be 0. Will it ever touch 0? No, it's behavior. It's like there's an asymptote at 0. It's leveling off there. Okay. So looking at this one, in the numerator, it's the 5x to the third. In the denominator, you have to be really careful here. It's not x squared. It's actually negative x squared. Okay, so that's what we're looking at. So which situation is it? The first, second, or third one? Okay, it is either positive infinity or negative infinity. So if you aren't sure, you can just guess. You got a 50-50 shot. What you want to do in this case, do you see how it's approaching negative infinity? We're going to imagine, do you have an imagination? You're going to imagine plugging in a really big positive number. You ready? If you take a really big positive number to the third, it is still a really big positive number. And then if you multiply it by 5, it's still a really big positive number, right? So the numerator is positive. I usually just like write a note to self. In the denominator, if you take a really big positive number and square it, it's still a really big positive number, but then you're going to make it negative, all right? So if you have a positive number divided by a negative number, it's negative. So it will be negative infinity. So at that point, you're just testing the signs. It's either going up or going down. So you just imagine plugging in a really big number and just see what the symbols turn it out to be.
So it's a positive.
Well, you're approaching positive infinity, so you want to imagine plugging in a really big positive number. If it approached negative infinity, you would imagine plugging in a really big negative number. All right, so looking at this one, who's in charge for the numerator? Yeah, x to the fourth, good. It's who's in charge here, all right? Who's in charge for the denominator? X to the second. Which situation is that? The first one, the second one, or the third one? The third. 4 is bigger than 2. So it is either going up or going down. Follow me on this. Now this one is approaching negative infinity. If you take a really big negative number to the fourth, why would it be positive? Even, good. If you take a really big negative number to the second, it'll be positive. A positive number divided by a positive number is positive, so positive infinity. All right, for this one, in the numerator, who's in charge? X, and I'm actually going to put the negative with that. It's going to be negative x. You see what I'm saying there? Negative x. In the denominator, it's square root of x. I want to see if anybody remembers this. If not, I will tell you, obviously, I'm your teacher, it's my job. What is the exponent when it's a square root? We did this when we did the logarithm. Oh, say that louder. Good, perfect, 1/2. So this is x to the 1, this is 1/2. 1 is bigger than 1/2, so it's a slant asymptote, all right? So we're gonna imagine plugging in a really big positive number. For the numerator, it would be a really big positive number, but then you would make it negative. So that would be a negative. If you square root a really big positive number, it's still a really big positive number. So a negative divided by a positive is negative. So again, if you figure out that it's this third situation, it's either positive or negative infinity. You're just checking the signs, right? This one's a little tricky. The numerator, yes, it's the 4. It's 4x to the nothing, though. And I do suggest putting that in there. There's not an x at all. It's x to the nothing. And in the denominator, we've got 3x squared. So which situation is that one? The first one, 0 is smaller than 2. So this is automatically going to be 0. Cool. I'm going to review a log property. And here's what always happens is everyone stares at me like they've never heard this before, but I did teach it to you. Do you remember how you're allowed to take the power and write it out front? Sort of. Okay, heads nodding, I'll take it. So it's going to be limit as x goes to infinity. And everyone in calculus is always like, do I have to write the limit part? And I'm like, yeah, because if you take away the limit, it's not calculus anymore. It's just algebra. Okay. So you have to write limit x goes to infinity. You're going to bring the 3 down. So 3 ln of x over that denominator. So then it's like, who's in charge here? Well, the numerator is that 3 ln of x. The denominator is 1 ln of x. Which situation do you think that is? Since they're both ln of x, which one of these is going on? Good, they're equal. They're both an ln of x. So when they're equal, you use the coefficients, which would be, good, 3 over 1, which would just be 3. Perfect. All right, for this one, in the numerator, it's the 3x squared. In the denominator, is it the x or is it the ln of x? X is a polynomial. Ln is a logarithmic. A polynomial grows faster than a logarithmic. So it's the x that we're going to look at. When it's who's in charge, it goes exponential, polynomial, logarithm. So this is x to the second, and this is x to the first. So which situation is that? Yeah, the third one. It's either up or down. You're just going to check the sign. If you plug in a really big positive number up here, it will still be positive, really big positive number. And if you plug in a really big positive number here, it'll be positive. Positive over positive is positive. But again, once you decide it's going up or down, it's either positive or negative infinity. You can just sort of guess if you need to. All right, for this one, we've got 2x in the numerator, ln of x in the denominator. This one's polynomial. This one's logarithmic. Polynomial grows faster than logarithmic. So it's a situation where the numerator, so to speak, is bigger than the denominator. So it's either going to be up or down. It's this third situation. And if you plug in a positive number, well, 2 times a positive number is positive, and ln of a positive number is positive number, so infinity, going up. 10 is a little bit tricky. I threw a cosine in there, but this is pre-calc, and we've done a lot with trig, so I believe in you. What does the cosine graph look like? You need to imagine that. Wave. It stays, now if you didn't stretch it or shrink it or do anything else weird, it stays between what 2 numbers? 1 and -1. So this numerator is going to stay between -1 and 1. In other words, very, very, very teensy tiny. It's going to stay between -1 and +1. If you imagine this denominator going to infinity, you end up with a situation like this. And that's poor notation. That's not actually a thing. But like, imagine the biggest number you can. And if you have like 1 over a gazillion, 0. Good. So 0 is your answer to the whole. So your numerator is bobbing between -1 and +1. But the takeaway there is it's very, very, very tiny. And your denominator is going to infinity. So if you have like 1 trillionth of something, that's leveling off at 0. All right, these last two, I'm doing a compare and contrast here. Do you notice how it's the exact same problem? Except for, what's the one difference? Positive infinity, and this one's negative infinity, and it is going to change the answer, okay? So when we go to do who's in charge here, who's in charge for the numerator? Good, all right, you guys have got it. I've successfully woken you up. 4x cubed, denominator, and exponential grows faster than a polynomial. So it's this one. Now, since the exponential grows way faster, you're in a situation like this first one, where the numerator is smaller than the denominator. Because yeah, like 4x cubed, that's going to go up. But an exponential, do you remember me going like this? Okay, so the exponential grows way faster. So it's going to level off at 0. If the denominator grows super, super quick, you end up in that situation like 1 trillionth. So this is really difficult material, though, because you have to think about infinity, which is something that we're not designed to be, like, we don't have that capacity. Do you get what I'm saying? So, like, think about it, but not too hard, I guess is what I'm saying. And then this one, you still have the 4x cubed in the numerator, but here's the thing. If you do a negative infinity, it flips that. And instead of being super important, it's now super unimportant. Do you get what I'm saying? Instead of being like a billion, you've flipped it and it's like a billionth. So we don't want that one. We want this instead. Instead of being super important, it's now super unimportant. So what do you notice about these powers? They're the same. What does that mean? Good. So it'll be 4 over -7. So -4/7. All right, so on this side, we're going to do the piecewise functions. Here's the only thing with piecewise. You have to decide which piece of the function you're plugging into. That's really it. It's decision making, like which piece of the function are you going to use? So if you get stuck, pick one and go with it. So, you know, give it a guess. And then you just plug in the number and see what you get. So this is divided up into 5 sections. For the sake of ease of talking about them, we're going to call them 1, 2, 3, 4, 5. So if I say like, which section are we plugging into? I'm looking for like a 1, 2, 3, 4, 5. Are you following me there? Just so we can communicate. All right. So when you look at this first one, we're approaching -3. All you have to do is figure out which section -3 lives in. And when you look at these, do you see how this first one is numbers smaller than -1? You're going to have to look up here though. Do you see how -3 is smaller than -1? It would be in that section. Okay, cool. Heads nodding. So we're going to use the first one. All you're going to do is plug in -3. Ready? Here we go. -3 squared, 9. And so your answer is 1/9. Again, that's all that there is to it. You just have to make a decision. And decision making can be hard. So again, it's one of those things that's like easy, but also hard. So which section does 5 live in? 5, the fifth one. 5 is bigger than 2. Okay, so we're going to plug 5 in. Ready? 5 minus 2 is 3. Good. 3 squared, 9. So it's -1/9. That's weird how they came out to 1/9, but one of them was negative, but just what it came out to. All right, this one is 3/2. What is 3/2 as a decimal? It's 1.5, 1.5. So which section, 1, 2, 3, or 4, or 5, does 1.5 for? Okay, do you see how 1.5 would be between 1 and 2? So if you plug 1.5 in, 1.5 plus 1 be 2.5. Good. I'm cool with the decimal or the fraction. Do you know what this would be in fraction? Oh, good. You guys are good with fractions. Like, I don't know. And just thinking back to previous years, you guys are awesome with the fractions. All right. Now we're going to start going to ones that are where it's cut, like where the domain got cut. So you have to look at whether it's from the left or the right. So this one says -1 from the left. It got cut at -1, but which one do you think, if you had to guess, would be the from the left? Like numbers to the left of -1. It would be the first one. That's where we have numbers smaller than -1. So we're going to use that first one. So if you plug in -1, let's see what you get. -1 squared. 1, and then 1/1 is 1. Good. So -1 is where this got cut. But see how there's a little negative? It says from the left. That means from the left. So that means we want the first piece. So look at the next one. Do you see how it's -1 from the right? So we would want the second one, and there's not really anything to plug in. That answer is just 2. Okay, cool. Now look, this is -1 from the left. This is -1 from the right. So when you go to do -1 overall, you don't even really need this anymore. Do these match up? No. Do you remember what kind of discontinuity that is? Jump discontinuity. And so good, this will be, does not exist. So if the left and the right go different places, it's a jump. So the overall limit's going to be does not. You kind of have to have an imagination and picture what the graph's looking like. All right, so now we're going to do +1. So look at +1 from the left. So +1 is where this got split. Where we have numbers smaller than 1 is right here. Do you see less than 1? Okay, so that answer is going to be 2. Good. And then we want 1 from the right. That would be where we have numbers bigger than 1. That would be this section. So if you plug in 1, 1 plus 1 is 2. Now, when you do 1 overall, you don't even need to look at the function anymore. Good. Oh, good. If the left side is 2 and the right side is 2, then this answer is 2. Now, here's what I usually get at that point. But Miss Cole, at 1, it says 3. Here's what happened. Both sides go to 2, but then the actual point is up there at 3. It's Nana fooled you points over here now, but the limit is still at 2. The point just was like, took it and put it up there at 3. All right, and then we're going to do 2 from the left, right, and overall. So 2 from the left, which section do you think you would use for 2 from the left? Yeah, the fourth one. Numbers smaller than 2. So plug in 2. 2 plus 1 is 3. Like the math you're doing is 2 plus 1. All right, 2 from the right, that's going to be the fifth one. So let's plug in 2. Oh my gosh, look, it came out to 2 minus 2, 0. That means there's an asymptote. It's either going up or down. And do you see that negative there? That means it's going down, so it would be -infinity. So when you go to do 2 overall, well, this one goes to 3, and then this side is -infinity. So that is like a very disjointed graph. Like what you have is from the one side, it was going to this point 3, and then you had an asymptote, and the other side was going down. Like it's very much broken, so does not exist for them.